So here's the gig about being the first presenter. If you don't like it, it's only going to get better. Okay? All right. So I'm going to talk about LLM pipeline architectures and risk management. LLM pipeline architecture, there's a lot of opportunity to try different scenarios with LLM pipelines. Some of you are building application pipelines with LLM. There are pros and cons to those. So I'll talk about that. And then with each of those, there are risk management principles that come into play. Some of them are more, are better from a risk management perspective, and some of them are not. And if you're aware of these risks, then you take appropriate control measures to do that. Okay? So quickly, when we were in the AI world, this is meant to be simple. You had your own data. You also had models that were well tested. And you had well-defined model risk management procedures that generally your outcomes were good and you could control them. Comes by Gen AI. You're using foundation models which are based on data that is crawled on the internet, C4 database, right? Complex black box transformer models. Suddenly things start to look a little scary. Then you're using these models, you're tuning them either through prompt engineering or retraining weights. Now you've got a solution, a generative AI solution. You have a lot more risk here, right? So a lot of the game that's going to be played in the next couple of years is, well, of course, the benefit of generative AI, but also how do you control for risk? And what do different architectures give you what in terms of potential risk and how do you control for them, okay? I hope that kind of resonates with you folks. When you think about LLM pipelines, a lot of work is being done on pilots. As you move into production, there are 4 kind of main building blocks here. Please come in, and there's some seats here. Let me put that out. Now, the block number 2 and block number 3 are well known. You're building foundation models, you're tuning them, you're building, taking those models, stitching together an application pipeline with input, the prompts, the RAGs, and your outcomes. Number 1 and number 4 buckets need mentioning. Data management, just like in the AI world, data management is very critical here. So when you think about data governance, if let's just say you were building a wealth management app where what kind of FAQs you expose to the LLM is very critical because some of that might be internal data which might be competitive that you don't want to get out. So tagging of that data becomes very critical. Data governance, data versioning. If you had the wrong pricing, you had a version 3 versions back pricing, and you're answering a question today, that could be a problem. So the data management process is very important. Whereas a lot of fascination focus right now is on the FMs and the tune models and the application pipelines. The last one is production ops. Is also very critical here because you want to continuously evolve and learn. Is it okay? You guys can hear me? You need to continuously evolve with the feedback. You need to collect that log, look at 2 sigma out responses that your pipelines are giving, and adjust your pipelines because this is still not an exact science. Okay? And I'm going to focus, double-click more on the block 2 and block 3. Okay? So basics. You have a choice of either building your own foundation model or taking an open source one or taking a closed source model, right? So those are your decision tree there. On the validation side, when you're preparing your use case, there are 2, think of a tree, there are 2 forks there. You have some standardized risks that you are validating for, so like profanity or copyrighted data, leakage of copyrighted data. And then you've got use case specific data sets that you're also validating for, which is your business use case, right? You have to tune the model. You have 2 choices there. You have the choice of either retraining the model or you have the choice of using sophisticated static or dynamic prompting. And finally, you're building the application out, right? So those are basics. Let's go further. So I'm going to share some live results of something that we did. CFPB is a regulatory body in the US, and they collect a huge amount, 2.5 to 3 million records of data for customer complaints. So one of the things that we did here was actually look at what are some of the core issues and classify all of these complaints into 3 buckets using LLMs. I want to keep going. This is an important slide that I'll cover. When you think about the LLM architecture pipelines, there are some decision choices you have in your hand. I can go closed source, I can go open source, right? I can go small model, parameters, I can go large parameter models. And lastly, I can retrain the model weights using fine-tuning processes, or I can do prompting and ragging. Bottom line, when you look at the chart on the right, you might get great benefit at great risk. On a risk-adjusted basis, you might not be that optimal. For your use case, you need to know where, if x-axis is model complexity and y-axis is risk-adjusted return, you want to be in that Goldilocks zone. Just think about that. That's a conceptual piece, but just think about that, right? And that piece might be different depending on where you are, what your use cases are. Okay, let's jump in further. So when we think about the open source models, we use a flat model. One approach is take the foundation model, fine-tune it, and off you go. Second approach is take the foundation model, this is a two-step process. Take the foundation model, train it on a dictionary. So we actually trained it on about 100 words, which are financial lexicon, and then we fine-tune the model. We got some very interesting results. Let's go to the results. So we got like a 0.8 on a F1 score, which is a performance score, of the two-step model versus the one-step model. If you can read that text on the top right, what you will see is that the domain-tuned model said something like this: a process where individual and businesses are attempting to resolve debt, blah, blah, blah. This is about something called debt settlement. And on the left one is actually what it should be. You can see some errors have crept in while this process is going on. But we got pretty good results. And what happens is like this. If you had a kid, you taught the kid how to eat. Now the kid can eat 5 different things, right? That methodology actually is very powerful in having a two-step process where you create essentially reusable assets with your domain-tuned model. Just keep going. I'm going to run short of time otherwise. And please ask me stuff after the session. If I take a large closed source model like ChatGPT, I have a couple of approaches. I can just prompt engineer it with chain of thought reasoning. We can talk about that, what that means later. I can take a small data set. We took about 250 records, trained the model, and we did something. We combined all of them together. We got pretty phenomenal results relative to the open source. The open source one with the two-stage model came close enough, right? Now here are where the trade-offs will actually happen. You will have to make the choice of cost, risk, and the outcome that you create, right? And depending on the use case, there is no one fit answer for all of this. Talk to me later, and I'll be happy to kind of brainstorm with you for your use cases. Keep going, keep going. All right, so what are the left side you can read. Let's look at the key predictions that I have, which is, I hope, somewhat unique. Foundation models are going to get utility. Open source is going to catch up with closed source models very quickly, which means OpenAI might have some issues with its valuation. Second, well, that's 12 to 18. In 12 to 18 months, the gap will reduce. Third, you're going to get a lot more low-code, no-code, custom GPT kind of what OpenAI launched, and now we've got that in Hugging Face. You're going to see a lot more of those. The area that needs a lot of work is the area of productionizing these LLM models, where tokens per second, the throughput that you're getting today is still low. It takes 7-8 seconds to inference an LLM pipeline. Okay? I can speak more on that a little later. AI is getting regulated. The EU Act is, as an example, is very focused on being able to produce safe, transparent, traceable AI. So they're concerned about this stuff. And now I've got a minute going, so I want to actually talk a little bit applying the EU AI Act to an LLM pipeline. In the pipeline, here are some examples of risks that you have. At the point of input, you have the risk that somebody could just ask a malicious prompt in to try and get something out of the LLM, which is not, or the LLM pipeline, which is not supposed to produce. You could have biases in the LLM pipeline. We talked about that, right? You might also have inadequate context. The prompt that is created is poor in that sense, so garbage in, garbage out. And is also, it's also susceptible to manipulation. In the LLM itself, hallucination. security and privacy concern. Does it leak copyrighted data, potentially, right? And then we look at the output side. You have situations of, is somebody over-relying on the results that the LLM produces? Misinterpretation of the outcome. So we, earlier, in banking, you have to be super careful about these outcome pieces, and over-reliance on them can create serious regulatory risk. My time's up. Thank you.